All right. Start live.
Hello, hello, hello.
There you go.
Hello, everyone. All right, Mike, it's all you, brother.
Well, you know, this is devOSH Live, weekly live stream where we work on open hardware design. This week, we're going to continue from last week's discussion about MakerChip, and we're going to dig in a little further, see what Kevin's got for us today. And there's going to be an after hours today, a small session to do some work on the project. So that is that. Last week we covered the basics of the MakerChip, and we also talked about the deveco.io, which Robert presented last week. It was interesting, and we might end up using it for projects for the devOSH effort. So I did go ahead and add another project to the potential projects this week. I thought of one that might be fun, which is adding an e-paper based design. So we have something of a reference for that. It would be probably the monochrome, but we could try to find the color versions of the e-paper. They're not cheap, and they're not super easy to source, but I think it'd be a fun project to show how to control them, how to wire up the e-paper. I've done this before, so I have some experience, and we can make that another project in the list. So that puts us up to 8 potential projects, and these are the projects that we will be working on throughout the course of the show, and any new projects that we are potentially wanting to work on, we would add it as first as a ticket on the repository, and then we would elaborate there, come up with a specification, and then from the specification we start doing the kind of the block level design, and from the block level design we go and start doing the schematic component selection, and eventually the PCB layout, and any mechanicals we would start from CAD drawing and kind of work out the dimensionals for enclosures or whatever we want to add on the mechanical side. So looks like Kevin's kind of getting prepared back there. It sounds like he's muted. Saying something?
Yes, you were right. I'm getting everything kind of set up here.
Okay. Yeah, so in the meantime, we can go ahead and look at the projects list, I guess. Go ahead and open up.
Yeah, if you want, you're welcome to go through the projects list that you have. I did make some updates to the GitHub repo for the MakerChip. You're welcome to jump in there and kind of do a quick pass, but I'll definitely, I think he jumped. I think Michael jumped.
He'll be back. I'm sure he'll be back. He probably accidentally hit a button. There, he's back.
Yeah, sorry.
I did that yesterday.
I clicked the don't click this button when I was opening a tab. I accidentally clicked instead. Let me go ahead and do this again. Yeah, I need to set up my alternate monitor so that I can have 2 screens. I'll just open up Chrome tab, new tab. Okay. You guys can see this one. All right. So you're wanting to suggest a project for our initiative. You would come over to GitHub slash the deveco slash devOSH, and then you would go to the issues here, and then you would add an issue here. Most of these were added by myself. One was added by Dale, which is a derivative camera project. So this is the one I added this week. Not a whole lot of details in here, but I can add details as I kind of figure out what I want to do with it. There are a few designs out there, open book, and other open hardware references that we can look at, like the Open Hardware Summit badge from 2018, and I think 2017, maybe. There's a few of them. There's plenty of them out there to look at. So yeah, I added that. And whenever I come up with an idea that I'm thinking, oh, that'd be fun to add to our project list, I'm going to add them here. And these are open for anyone that wants to contribute and say, hey, I want to work on this particular project. We would assign the project to the person that wants it. And of course, start adding comments here, and then formalize the specification. It'd probably be best to do the specification in probably markdown format or something, like the rest of the files here. You would have to create a project for our projects. We do sub modules so that we don't have all the projects rolled into one. So you would, after you assign the project to yourself, you would create a repository on your personal account and then start working on it there. So what I, for reference, there was, today
You mind making your font a little bigger there, Mike, please?
On the screen?
Yeah, there you go. That's better. Yeah, that's better. Thank you.
Yeah. All right. So yeah, today we're talking about MakerChip. So these are the 3 projects that we've started, and this one's pretty much finished. This one's mostly finished, and this is the one we're working on, MakerChip. So you if you have access, or you're me or Mark or one of the core group, then you can create a repository within the devEco space. But this isn't strictly required. For the Bevy LED, I went ahead and just used my personal account and moved it over there because I wanted to kind of keep the pattern the same and give an example of, you know, what it would look like for an outside contributor. So you create a repository. A good thing to do when you're creating these repositories is to use a nice KiCad git ignore, so that it gets rid of all the backup files and temporary files. You don't want to commit to the repository. And you can use the one that's in here. I'm considering making a boilerplate or template KiCad project so that you don't have to add the git ignore yourself. Maybe have like an empty project or the likes. I'm using KiCad 10 for all of my designs. That's what is installed on my development box, which is running Debian 4key. So that one's what we use, or at least what I use. You're not strictly forced to use KiCad for the design, but I recommend it, especially if you want to have collaborators and you don't want them to have to buy software or use some web-based design or whatever. It's not something that I'm going to say, no, you can't contribute if you use one of the other packages. It's just not as easily available to everyone. KiCad is kind of the way to go for collaborating with me, because I can use it, and we can. I would recommend using the newest version.
Yeah,
Which is KiCad 10.
KiCad is definitely the best for collaboration. There are a couple other free platforms, Easy EDA, that has pretty much all the same features, and the benefit of that is you can integrate vertically. They have their product catalog, LCSC, connected directly into Easy EDA, so you have a little bit of an easier time sourcing your parts going through there.
Yeah.
But ideally, it should be reverse compatible, but every now and then it's kind of get difficult. So I would definitely recommend sticking
Easy
in there as
EDA.
well. Mm-hmm.
Okay, and I wouldn't be strictly against it. I just all the parts that can be had in Easy EDA are available in KiCad. If you don't have them, you can make them.
Mm-hmm.
If there's I think there are LCSC component libraries out there, but
Yeah, I'm
for
pretty sure there's a
passive
plugin.
and stuff like that, a lot of those passives you don't have to do any special component footprints or anything. And a lot of the parts that you can source there, you can source other places.
Mm-hmm.
I typically use DigiKey or Mauser or something here in the US to buy the parts, because I don't want to have to deal with the tariffs and the payment methods and all this stuff. I know that a lot of people use LCSC because of cost, and usually that's kind of the driving factor for commodity hardware. But for specialized design, embedded hardware, I use Arrow or DigiKey or something like that. And I don't single source usually, because sometimes it's just not possible, but other times it's just it makes sense to kind of go to a different place for specific parts, either due to price or just availability. So yeah, I usually just kind of stick to the KiCad core libraries. If they don't have a component there, either I'll create a local library or a global library that is kind of shared between the projects. For devOSH, since we want to make these designs something that other people can leverage, it's probably best to create a global library for everybody to use if there are new parts. And it hasn't come up yet, but when it does, I'll probably create a component library for the devOSH repository, and then it can get pulled down and used locally with some settings. And if anybody has any questions, if they get stuck with KiCad, they can ask me, hey, what do I need to do here? Where is all this? I get these questions on my Discord a lot from a number of people, because I've used it for long enough. I kind of know my way around, or if I don't, I'm pretty good at Googling things for people. And that's kind of how it goes. But yeah, so that's kind of the rundown of the current state of the repository. We got 3 projects. This is project 3 that we're working on here. The maker chip.
Mm-hmm.
Let's go back to the main repo and check into, okay, so projects, maker chip. So let's go ahead and check if anything was added recently. It looks like there was some, okay, looks like we have some development here. So looks like we added proto board snapshot. Okay, so this is something that is very specific to you guys.
Mm-hmm.
So it's encapsulate AI tools and kind of guides the hardware development process. So I'm guessing it'd probably be best for you to kind of go through what you have here.
Yeah.
So let me go ahead and drop the share, and then you can go ahead and share, because that would be probably easier.
Yeah, I've got a lot of updates that I can share over.
So yeah, let's go ahead and get into it with the maker chip. Let me stop sharing real quick. Okay, now you can share.
Oh, 1 second, it is loading.
Yeah, and I apologize for not trying the proto board. It's just I don't.
No, not a
Usually
problem. Not a
kind of-
problem at all. I'm gonna do my whole screen here. It's having some issues with the window specific. Okay.
Yeah.
All right.
It's fine. So okay, so it looks
Open
like you
up
have an
that.
EZDA design that you want to show.
I do. I want to show it just because that's where I made my initial design. I'm actually transferring over to the KiCad for compatibility, just working across. But I don't have that finished yet. So
Hey guys, I'll
Okay.
be back in just 2 seconds. Okay.
That's fine.
Okay. Yeah. As long as you guys have this screen share up right now, you should be fine. I'll just be back in a sec.
All right, cool.
Maker chip standard here. All right. So the first thing I want to actually talk about, and I'm assuming you can see my screen here.
Yeah, it's a little small. Maybe zoom in like another notch. That's good right there.
Perfect.
Yeah, that's good.
All right. Let me close that from popping up here. I'm doing the noise. No.
Yeah. Looks like Discord's popping off back there.
Let me close off Discord here so I don't get notifications for a hot minute. There you go. Okay. All right. So the first thing I want to talk about, I kind of prototyped some definitions and a versioning system for the maker chip standard. Now, the original one was originally inspired by Kevin, K2 over here. And if you go to their page, it takes you to their Maker World page where you can 3D print, you can design your own. Yeah. So this is what the original inspiration was from. This is still a phenomenal project, but we wanted to upgrade from here. We wanted to make Maker Chip 2.0. And so, of course, I deleted it. Go back. I do not have this favorited yet. I should probably do that.
Hot link.
Go ahead
Yeah,
and
so
do
you
that.
can
Yeah.
go right back to it.
Let me just add that to my bookmark real quick. Maker Chip. Good. All right, that way I can find it again. So version 2.0 was essentially augmenting the original 3D printed base. And this concept here done by the great Robert himself, a quick little sketch. Actually, I don't know if this was done by Robert or not. This may have done by Mark.
I think Mark did it.
Here. Okay.
He did it based on feedback from us, essentially. He
Perfect.
made a quick sketch.
Quick sketch of things we could potentially move into from, standardizing the size, the thickness of the actual chip itself, magnetic placement for, quick mounting, augments, things like that, and then moving over to adding electronics and sensors and displays and LEDs and things like that, and kind of moving up the chain. And I wanted to kind of upgrade on top of this. The original CAD file here, which this link here will take you to the Onshape file. It should be a public project.
Yeah.
And this was a very simple proof of concept. You have your magnet in the base, which is polarized, south, north, reversed, so that your magnet lands in the same direction every time. And this becomes important when you start adding POCO pins, data lines, information, that having the wrong pin connect to the wrong thing could be not so great. So moving on, I wanted to create a versioning system where anyone could jump in here and understand exactly where their version falls under. And I'm going to skip ahead here. There's plenty of information, but here is kind of a really quick example of what that would look like. So Maker Chip 1.0 was the plain old 3D printed disk. It could have been multicolor, single color. You could have, added UV printing on top of it, laser engraving, anything like that. But its core idea was just a 3D printed thing with a logo on it. And
Purely mechanical.
moving up the chain here, adding a simple NFC sticker. So you print your chip, you pause it, you add an NFC sticker, and then continue to print on top of it, essentially encapsulating the NFC sticker embedded inside the chip. You now have some functionality where you can add a URL to a website, you can have a code to open something. It can be a point of action.
Yeah.
Going from
I've
there,
seen a few of those at Open
Yeah.
Source last year.
Yeah. And so it's essentially taking the idea of, okay, so you have your base model, the MakerChip 1.0, and you're augmenting it, you're modifying it with smaller version numbers that kind of encapsulate what you're trying to do. And this is just an example, and I wanted to get your feedback here, Michael, on exactly if this is a good way to do it. But moving on from there, the MakerChip 2.0 is as simple as just adding that magnetic interface, adding that really satisfying snap to the MakerChip, and then moving up from there. So 3.0 would be a PCB, 4.0 would be self-powered. At some point, some really clever people, probably smarter than me, will figure out how to add a battery, like maybe a system, an SoC battery, or wireless charging of some sort. And then finally, version 5.0 and up is kind of your experimental zone where you can add motion, you can add functionality. And I don't know if you've seen any of the videos, but there's a gentleman on YouTube, and I'm not going to pronounce his name because I will butcher it, but he's made micro PCB motors where he's embedded the coils inside the PCB. You could technically do something like that for this chip, given that you have a dock that you actually connect to and power the device. So there's a lot of really cool things you can do here. For example, adding an e-ink display, like you said, maybe we could turn that into its own project, or we could do a magnetic levitation chip, where if I go to Maker World here, actually the faster way to do it would be Discord, but that's okay. Maker World, Maker Supply, and then I'm looking for mag. Here we go, this project. So obviously this is an expensive version that's kind of pre-made by Bamboo Store, but it's got all the bells and whistles you need to make this project happen. And what you could do is have this chip embedded inside of your poker chip, and so essentially it could float on top of that magnetic coil. And I've got some examples here of things that people have done with the actual
floating 3D prints. This is
so there's
thing.
A lot of really cool things you can do there. And so going back to the actual GitHub repo here, I went through and kind of gave a ton of different examples on how that would look going all the way through the versioning system. And I wanted to get your opinion, Michael, on whether or not this is something that we wanted, if this was the best way to label different versions of Maker chips. Because for me, I love the ring of MakerChip 2.0 or MakerChip 3.0, and then just having a variant inside of that category. I just felt like it was easier for anybody that wanted to jump in. They don't have to start at MakerChip 1.0. They can start at any point along the way, and then just contribute to the project with whatever they have.
Yeah, and I think making their own version of something, and attributing the project. Hey, I learned how to do this from this repository, and I made this version of it. And once you pick the version, I think the versioning is fine. Usually it's either that or like a letter mnemonic. Like for magnetic, you'd use like M or something. But I think just 1.0, 2.0 is fine. I don't think that it makes a whole lot of difference as long as there's clear definition in the taxonomy here, which you already have. As long as we keep it standardized and we don't change like version numbers to mean different things along the way. I'm assuming that once we do this, the original Makerchip person might come up with varying versions, and then we'll be kind of conflicting there. So it might be a good idea to contact them and reach out for feedback from that side. It seems like a fairly open project, and it's made for kind of a community collaboration and kind of sharing. So I don't think that would be a big deal. As long as we communicate with them, I think it could possibly make it less contentious in the future. So
Absolutely,
we can maybe reach out to them.
Yes, I agree with you. I think that would be a smart plan, not to create any conflict there. Obviously, if they're working on something I haven't heard about it, which very well could be the next thing that they're working on, and in my opinion, I think the best time to reach out to them would be with an example.
Of course. Yeah.
Of their Makerchip. So let's say we build a PCB and then we present it and say, hey, we're trying to upgrade and make this a standard. Like, would you be willing to be a part of it? I think that conversation would go over really well. So yes, I think that's a great idea. The big question here is, you've got your core standards. It's a 40 millimeter chip. It has this, thickness plus or minus whatever. The orientation, like it has to be polarized, like whatever the stack goes up and down. The core idea is that it's compatible up and down. It's backwards compatible and forwards compatible. So your printed chip can fit inside of a typical dock all the way up to 5.0, and your magnet is consistent throughout the versions so that everything is essentially compatible throughout its history. And that can change over time. We may want to upgrade or change the magnet standard to something potentially better in the future. And so we can kind of update that through different means. But the main unknown for me here, and this is kind of what Mark, my co-founder, brought up, was having the major version number is fine, but the minor version number is kind of vague. You can have an infinite number of variants and technically an infinite number of minor versions. So I didn't know if we wanted to lock in a major and minor versioning system if people are going to go off of the core base.
Yeah. Well, you could have if they want to make a variant of a minor number, they can have like a third or a triple, and they say, okay, I'm 3.1.5 in my version. I changed this thing a little bit, and they would specify that somewhere, and then maybe we could roll it back into the standard. But you don't want to make multiple standards, because then everybody's doing something different, and just chaos ensues.
Yeah, and I don't want to make this confusing. I don't want a user who wants to contribute to the project look at this repo and be completely overwhelmed and think, there's 10 different 3.0 versions that all mean different things. I don't really know what mine falls under. So I wanted to be careful on exactly looking ahead and making sure that we're not over engineering this whole standard, and just making it a fun collaboration bit that we can work off of. So that was my main question on, in your opinion, what we should do there.
So I think guided like taxonomy, instead of just using the numbers, like ask them what features that they want, and then you would give them the number essentially based on that. So they can kind of, and if it's something new, then we can amend the standard, and that would go through a process, like a formal approval process. So every time we add a new feature to the standard, we say, okay, this is added as a kind of interim change, and we go through and review it and test it, try it, make sure that it works, make sure there's no gotchas with it, and then add it to the standard. I think making it easier to find what variant you want would be nice. Maybe like a too long didn't read guide. Like
Mhm.
if you want a magnetic one, then you're 3.0 or 3.x or whatever. Maybe right up top of this, have like a summary of the different variants. I think there was right. Let's see.
Well, I've got a
Yeah.
TLDR at the very bottom here.
Okay.
And questions like this is super open-ended, and I really just wanted to get eyes on it first before really committing to a bunch of new stuff. Contributors guidelines. So actually, I don't have a TLDR. I could have sworn I had one.
Yeah, you have the contribution guidelines and warnings, and then naming. So the naming goes Makerchip spec and then kind of variant, it looks like.
Mm-hmm. Yeah, that was my original idea.
Okay. Yeah, the numbers might throw people off thinking it's like a different size or something, but I do like the compatibility matrix that you have here, and I think that'll help people select kind of where they're at. I think that's a good thing to do, and then you can give examples of each one, like along the way. If you don't have an example, then you only have drawings of what it should be. It's not as a concrete of an example. People will get like there'll be questions, and with questions, comes like possible changes to the standard based on what they need, instead of just giving the exactness of what you want for that specific version number. So I think it's good. Like this is sufficiently broken out to the point where somebody could look at this, and it's not terribly long, and they can figure out what wood category they're in and kind of go from there. And I think a lot of times people come to you saying, "Oh, well, that's really cool. How did you make it?" And then you can actually point them directly to the standard that you used, and that way, that standard will be right there, ready for them to fork and modify. So that it would be like kind of a boilerplate like design with, I don't know, like add logo here, add LEDs here, whatever, So
well, and that's exactly the next question here is my goal was, this was a really quick rough draft, and my goal was to add examples, images to every single section so they understand visually separating what each one of these means. And it's as simple as saying, 2.0 right here, having the magnets in place for the matrix would have an image where you have your actual PCB here or your chip, and then you're seeing a screenshot of a cross section where, as it loads,
yeah, where you would stop the print and then add the components.
Yeah, and okay, it's far away. There you go. So this is not one of the chips. Of course, it's not.
Looks like a stack or a holder.
It's actually a holder. I've actually got a new version I'm working on. I'll talk about that later. But so cool. You have your chip here, and let's say this is a batch. So you're making a bunch of them, and I've got a pause set up here so that at this layer specifically, the printer stops, notifies me, and I can add stickers to NFC stickers to each one of these, and then continue printing. And NFC so we would have, a screenshot of this process here and just explaining exactly how that works, looking at the actual files here. Sorry. looking at the actual settings here, what the recommended settings are, and things like that, to at least guide the user on how to actually properly set all that information up. So the idea is over time, as we build an example for each version, we have a screenshot, we have several images or examples that they can look at. And I say for every version number, and this doesn't have to be all at once either, we can do this over time. For each version number, we have an example boilerplate. So
Yeah.
I'll use 3.0 as an example here. Let me go up. 3.0, so the PCB stack here. In this instance, we would provide KiCad files. We would provide bill of material files. We would provide protoboard files so that a user actually understands how everything is connected and how it all works together. And from there, they can jump off and build their own because they've already got that boilerplate KiCad file that they can jump off from. And whatever contribution we get from that point, we can do a pull request, we can put it into the official repo, into main, and then they might have other examples, official examples that they can pull from and build off of. And so I feel like that's a really good community kind of building towards really cool examples.
Yeah, a spring point or a stepping stone so that you can kind of guide their way through the process and hopefully they don't get stymied by the technical debt. It should be that bad though.
And so here's kind of my solution for the technical debt. And this is not a product plug. It's genuinely what's incredibly useful to use here. So for this PCB design here, and I'm going to pull this one. And this is Easy EDA, which is getting transferred over to KiCad eventually here. Okay. But this project right here is a 3.0, MakerChip 3.0. And I have a exclusion zone for the magnet where it would sit. And then I have actual LEDs and other micro components. And if I go to the actual schematic here, you can see the full rundown. So I've got a not a microcontroller, an MCU here. Okay. And it powers a bunch of LEDs here. Ground, VCC.
Is that like an AT tiny?
Yeah, actually. Let me look at the actual. Let me go to proto board real quick. Let me pull up the board.
You have a proto board project for it. Okay.
I do. The desktop.
And it should be noted this is not a necessity. It's a facilitator for people that might want to use it.
Yeah, that's right. It's completely free to use. You can hook up any AI agent that you need to it. It's got a built-in agent if you want it. Okay. But moving into the actual MCU here, it's a AT Tiny 85, and if I open it, it actually tells you everything that it's interfaced with. Every connection, every pin, kind of everything that is put together, connected to. And visually, you can see that here as well. So you've got your individual pads, what they represent, your LEDs, your resistors, all going to ground here.
It's a very nice block level design.
Yeah, and the idea is for you to understand at a system level exactly how all these different components work. And what's really fascinating is if I wanted to, I can pull this aside here. I can open up an instance of Claude Code. And I have a dangerously skip permissions mode because I like to live dangerously. But if I ask it, can you connect to... Oh, it's frozen. Come on. My computer is not the best at RAM.
Yeah. You can't get more right now if you want it.
That is very true. That is very true. To put a board.
Unless you're a billionaire.
And then I'm going to actually share the URL because I have a repo on this computer and it likes to find the repo as well.
Okay. Slytherin. Ooh, that's a lot of tokens. Tokens.
Okay.
Are you using Anthropic or yeah? So this is going to cost you if you use too much, right? So
Yeah,
that's something
absolutely.
to
So,
consider.
and just like any AI, CLI tool or any API tool, including the one inside here, every user gets a certain amount of free credits that
Yeah.
refills every single month. That we offer included, but AI does cost a lot, and so it is a very helpful tool, especially if you're just learning on trying to figure out how everything works. And the neat part is all the tools that you have access to in the app, the AI has access to as well, which means you don't have to use AI. Everything can be built manually. It's just a lot faster and it can help you learn in a very iterative approach. And we just
That's
had
me.
great example. So it's kind of a good bridge between the two. And so in this instance, can you add another LED to the board? And so it understands the entire project context. It understands every single component, how these things are connected, and it will start looking at figuring out how to add another component. So I'm assuming this is going to add another instance of LED and resistors since those two are required, but we'll see.
Yeah.
There we
There's
go.
one. And it
Okay.
just added a white LED.
Okay, and it requested want me to add another.
Yes.
Yes. Can you add the resistor and wire
You'll definitely need the wiring harness.
everything up? Okay, and so now it's going to think about, okay, so I need to add the resistor here, and I need to add the connections between ground and VCC. And the interesting part here is this this tiny here is pretty much at max capacity. So I'm curious to see what it says, what it tries to do here. If it's going to ask me what I need to do next, or if it's going to go ahead and find an opening for me here. So
yeah, upgrade your MCU or add a GPU expand or GPIO expander or something like that.
Yeah, and the cool part is before I built this project, I had different versions, and I'll let this run in the background here. So I went ahead and uploaded an image of what I was trying to create, and I gave it a description of exactly what I was trying to build, and I gave it some requirements on exactly what I wanted to have inside of it. Notes is kind of a scratch pad area where you can interact with the AI in a easy way, but the idea was I gave it a requirement that said, hey, like this is a very tight space constraint PCB that's going to have multiple layers. And for example, you've got your bottom, middle, and top layers of your PCB here. And so with those constraints, it was able to find components that could fit on that platform. And if I open this up here, it recommended these components to me. None of these were my own decisions. I looked at them and verified each one of them, but every single one of them fit the requirement. And if I actually turn this in, it fit the height requirement. It fit the space requirement. And here's my logo superimposed on top of it, the Delta Robotics logo. But you've got your LED and your resistor, which are absolutely tiny, way smaller than I expected.
201s? Yeah, those are going to be fun to solder.
Yeah, and this is kind of that iterative approach. You look at this and say, wow, those were a lot smaller than I expected. This tiny here is actually a good size. It's a good size for what I want. And so I'm going to make a change and said, okay, I either want a lot more of these LEDs or I want bigger LEDs that have better throughput, or that are brighter, that have RGB or RGBW. With this tiny here, you can program this chip to do like LED patterns. You can do if I added a little bit of a memory here to this circuit, I could have it replay a logo animation, or have that kind of memory built into the chip.
Yeah.
And at the bottom here, you can actually see the pads. These are the copper pads where the pogo pins would actually interface with a dock. So you have essentially a negative of this design and spring-loaded pogo pins at the bottom. And the magnet, and from this design here, you've got your occlusion zone. So your magnet is perfectly positioned to provide even push pressure on the pogo pins here, so that you have good consistent contact. But just for compensation, they're oversized, and so there's enough for wiggle room for slight rotation, and even if there's uneven pressure on one side, it'll still make good contact with the amount of space that it compresses. And so all of these design considerations was something that I honestly, it was not really, I'm a mechanical engineer, and so I had no idea what components to get for this specific circuit. I knew what I wanted, but I used Protoboard, the software that we've been working on here, to really figure out exactly how to do that. So coming back to the LED here, it looks like it added it directly to the MCU. So I'm curious to see what it says.
It says power. It doesn't have a GPIO, so it just powered it.
Interesting.
So you can't turn it on and off.
That's funny. Okay, so yeah, same PWM signal, they blink together.
Okay, so it's 1 in 5.
Mm-hmm.
Okay.
Yeah, and being a mechanical engineer, this is not something that I would have recognized as something to look at. So having that conversation and going through this, iteratively, I could have realized, oh, actually, I think I want to stick with 4 LEDs, unless I have some sort of array, which I don't. Yeah. That may be version 4. We'll get into that later. But
I think that you'd probably want to consider different topologies depending on how many you wanted to add. To consider Charlie plexes or serial LEDs. That makes it much easier. You could use this tiny and drive hundreds of LEDs if they are using like the NeoPixel style. Those are a little taller though, so you'd have to check if they beat your constraints. And I think you could probably say, hey, AI, I heard about these LEDs. Can you look at that? And I think that's pretty much NeoPixels, or and then you could add a lot more LEDs with a single GPIO pin kind of thing. Looks like we got a little bit of feedback from Mark. He's planning on adding a harness topologies. Okay, cool. For different harness types. That's interesting to see.
Yeah, and this is a continually developing platform. So the idea is we want to help you design and build your ideas. The reason I'm bringing this up here is for this MakerChip project, I wanted to build us personally for open source software. I want to have a custom LED with our logo on it that interfaces with a magnetic dock that lights up the LED. I felt like that is a huge upgrade to the existing MakerChip 1.0, and I wanted to show off exactly the steps it took to get there. And if I go to the actual GitHub repo here, go all the way
up at a version 3, right?
Version 3.0, and that's the PCB standard. But in the docs, and there could be a better place to put this, I included a protoboard file where the bill of materials, the plan, the session, like I even shared the session conversation that I had. But the idea is this project right here, this is a live board. If you click on that link, it'll actually send you to that project where you can now you can save and build your own version of that MakerChip 3.0 project. And I felt like that can really help tie together a lot of people who want to contribute but don't know where to start. I felt like that was a really good way to tie everything together.
Yeah, and I think the kind of the purest route, the non-AI route, would be good to kind of
document. Of course. This is, we're not replacing. We're not supplementing, or we are supplementing. This is for engineers. We want this tool to be something that helps them to build and test ideas faster. So maybe the initial prototype is a quick draft, and then you jump into KiCad and start building out the full design. Our goal is to really have integrations built in, KiCad integration, Onshape integration, and anything any type of artifact, coding integration. The cool thing with letting Claude Code connect to your protoboard project here is the fact that I can tell Claude Code my entire project with context, with connections, interfaces, pinouts, everything, and it can immediately start working in my code base, let's say a VS Code project, and start building out the software, start building out the firmware.
That's cool.
For that component. So that's kind of the powerful aspect of it. But I have one more thing to show off. This is kind of a packed episode.
Sure.
A packed session here. Okay. So I've also been doing a lot of work on the actual model itself. So this is the original design that has the, and I'll do a cross section here. So this has the embedded magnet. Oh yeah.
Question on the chat. He just asked if you explained UHD.
Oh no, I have not. I'll get into that. I don't want to. This session is about the open hardware stuff, and I don't want to take up too much of the time. But I will mention it at the very end. We have an open source standard that ties together all of the hardware, but I'll jump into that after I talk about this one.
Okay, sure.
So this is a CAD model for the one that the prototype that I made, the image that I had inside of protoboard here. It's a simple embedded magnet design. It's got a really powerful neodymium N52 magnet, and it gives you the best pop feeling possible. It snaps in, and it just feels really incredibly good. And this model is available on the actual, you click that link right there, it should take you to that model. If not, please let me know, I will fix it. But you can download this yourself. And the cool upgrade I recently made is a hat clip version.
Oh, yes, I know Fixer was asking for this.
Yeah, in fact, I am going to unshare my screen real quick here. Zoom in. I'm actually wearing it right now.
Okay. But
it doesn't have anything on it.
A logo or anything. Okay.
Nothing yet. I'm working on adding a logo, and I've got a couple designs that I'm working on right now. And so hopefully for the next session, I'll have a bunch of examples that I can show off. But
excellent.
This fully 3D printed hat clip designed to fit. And I've got the embedded magnets in here as well. And excellent. So this was a special request from Robert, and I just wanted to show.
Mine.
His idea has come to fruition.
It's taken it's almost a year or two.
Falling into place. You know, we had a couple of iterations of the clip, but we never had the magnets actually embedded in them yet. So this is new and exciting.
It's cool. It's cool because it's typically you've got a 5 millimeter thick section there, and from sitting on top of the hat, it sits pretty proud. It's not terrible, but because the magnets are so strong, I actually designed it to be inverted as well. So you can actually sit on top of, have the magnets sit at the bottom, so it's not as high profile. So there's a lot of cool things you could do with it.
Wow, the magnets are strong enough to go right through the hat and the clip. Wow. Okay.
Yeah, and I don't have this design yet, but if you add a steel backing plate to the magnets,
Yeah.
you can. I don't want to get too detailed here, but you can divert the magnetic field in one direction and have an even
Right.
stronger magnetic field. That would be way better than just the magnets by themselves. So there's a lot of cool things you can do. You can do with that as well.
Hey
Yeah.
guys, we might have to take this to after hours soon.
Oh yeah, we
Okay.
are at the hour.
I'm pretty much done. I was going to mention our open standard, but that's pretty much all I had to talk about for today.
Okay.
Those were the updates.
We have 2 minutes, so that should be sufficient to talk about the standard before we
Okay.
call
Yeah.
it.
Sure. I'll do a quick pass forward here. So one of the things that we found that was incredibly important was as you're editing with AI, you have to be able to trust that what it's making is accurate. There's a lot of slop out there, and if you can't verify that the components actually go together, then it's kind of pointless.
Yeah.
To have that standard here. So I am going to go to, let's see. I don't have this one favorited either, so I'm probably going to get in trouble by Mark here. UHD right here, Open UHD.
Okay.
So yeah, so this is another open source repository, and we came to the realization that in order for AI, in order for humans to both look at the same file, the same project, the same part, and be able to understand it at a fundamental level, we had to create a description that could cross the hardware, electrical domains. And that's where we came up with the universal hardware description. We're not new. Okay. We're not the first people to think of this. In fact, this is inspired by Verilog, the standard that they made for the silicon industry. We kind of took that concept and brought it to a developer board friendly system. So it talks about your interfaces, it talks about the resources, the pins, configurations. And our goal here is to make this a universal standard, have all of the projects inside of protoboard so well defined that you can take this and put it into a CAD software and it be able to recognize what you built, or bring it into a coding software or a simulation platform and understand that system in components individually here. And we have this, it's brand new. So it's like we just launched this. We don't have a whole lot of information in here yet, but the idea for us is we want this to become an open standard that everybody can use and build on top of, so we don't have to keep working on top of each other.
Excellent. Yeah, maybe we can have a whole other episode just on this, because
I'll definitely have
probably a lot of details to go over.
There's a lot of details for sure, and we're still developing it and adding examples and things like that. So, and I'll probably have Mark lead that because it's kind of out of my element, but absolutely. But yeah, those were the big major updates. Makerchip is slowly but surely becoming a thing, and I'm confident that I will have some 2.0, 3.0 examples, prototypes at Open Sauce this year. That's my goal.
Excellent. Awesome. Yeah, and I'm gonna make my own version. It's gonna be awesome.
Fantastic.
And I'll make it secret until I show up.
Okay.
So I think it's about time to wrap up the hour. You want to put in any last comments? Talk about what we might do next week.
Yeah, if you want any, if anyone wants to head over to devEco.io, go check that out. It's in like early access, open alpha, I guess you could call it. But feel free to go make an account there. Good place to kind of get started, at least get familiar with the devEco community. Open source content platform. We talked about that last week last week. If you enjoy what you're seeing here, make sure you like and follow the channel. Make sure you like the video, follow the channel. And we're here pretty much every week now. Sorry, I'm usually more active, but I'm a little bit under the weather. And so at least I say like I think I'm under the weather because I'm just not feeling so good, and I'm feeling more like I just need to sleep some more. But yeah.
Yeah, I've been there.
So yeah, that's why I've been pretty quiet. But yeah, thanks guys. You did a great job. This was awesome. It was good to follow along.
Okay. So I guess we can call it for the week, and we'll see everyone next week.
Okay, let's close.
Awesome. See you guys.
Later, everyone. Bye.